Apache Spark is one of the most widely used frameworks when it comes to handling and working with big data. On the other hand, Python is one of the most widely used programming language for data analysis, machine learning, and much more. So why not use them together? This is where Python with Spark, also known as PySpark, comes into the picture. So hello and welcome guys, I'm Atul from Intellipaat and today we are here with an on-demand tutorial on PySpark. So without delaying any further, let's quickly jump to agenda for today's session on PySpark tutorial for beginners. So I'll start this session by giving you a brief introduction of PySpark. We'll discuss things like what is PySpark, why PySpark, what are its various advantages, and once we are done with it, I'll show you how some of the big tech giants in the market are using PySpark in their development. Now by then, since you guys would have a fair idea of what exactly the PySpark is, so I'd move forward to the installation part, where I'll teach you to install PySpark on your machine. Well, if you want to get the most out of this tutorial, I'd suggest that make sure that you're performing the demo side by side. This way we can have an interactive session and you can post down your doubts in the comment section below. And we'll try to reply them at the earliest. So once we are done with the installation, we'll finally end this session with the Spark Fundamentals, where we'll discuss about the Spark config, the SparkContext, Sparkfiles, RDDs and data frames in depth. Don't worry, I'll make sure that I take some relevant demo which will give you a better idea of these topics. I hope the agenda is clear to you guys. Shall we move forward? Okay. So let's start with our very first topic, Introduction to PySpark. You know what? The average salary of an Apache Spark developer is around $110,000 per annum. So there's no doubt that Spark is used in industry a lot. Now when it comes to Python, because of its rich library set, it is used by majority of data scientists and analytics experts today. So combining both the Python and Spark was a major gift to the community. Spark was developed in Scala language, which is much like Java. It compiles the program into bytecode for the JVM for Spark big data processing. So to support Spark with Python, the Apache Spark community released PySpark. So guys, what do you think a PySpark is? Any rough idea, anyone? Okay, fine. I'm assuming that you guys know that it is something which has to deal with both Python as well as the Spark, right? Since I already told you that Python is an open source, powerful, high level and object oriented programming language, and yes, in terms of its syntax, it's way easier to use and read when compared to other programming language. On the other hand, the Apache Spark is an open source, general purpose distributed computing engine which is used for processing and dealing with large amount of data. So here comes the PySpark. It's a collaboration of Apache Spark and Python. It is an API for Spark which easily integrate and work with RDD using the library called Py4j. So let me tell you, PySpark is an API where you merge the simplicity of Python with the power of Apache Spark in order to tame the big data. For those of you who are already familiar with Spark and the concept of RDDs, for you guys, you can think of it as a Python API for Spark which easily integrate and work with RDD using a library called Py4j. This PySpark, it offers a PySpark shell which links the Python API to the Spark core and initializes the Spark context. I hope by now you guys have a brief idea of what is PySpark. Alright. So let's move ahead and let me tell you about some of its advantages. This will help you to know more about why you should use PySpark. So like we can see here, we have speed, powerful caching, real-time computation, deployment, and polyglot. So on number one, we have speed. So when you compare it with the traditional large-scale data processing, it's definitely 100x faster than them. Alright. In terms of powerful caching, well, PySpark will give you a powerful caching with disk persistence capabilities. On third, we have real-time computation. Well, there's a plethora of data which need to be processed in real time. Let me tell you a fact. You know what? Every minute, around 48 hours of video is being uploaded on YouTube. Twitter gets around 98,000 of tweets and more than 168 millions of emails are sent every single minute. Well, these data comes in bits and pieces from many different sources. It can come in various forms like words, images, numbers, and so on. So Twitter is a very good example of words being generated in real time. We also have websites where statistics like number of visitors, page views, and so on are being generated in real time. There's so much data and they're not useful in their raw form. We have to process it and extract insight from it so that it becomes more useful to us, right? So this is where Spark Streaming comes into picture. It is exceptionally good at processing real-time data and is highly scalable. It can process enormous amount of data in real time without skipping a beat. Alright. Next feature we can see over here is deployment. Well, you can deploy PySpark through Mesos, Hadoop, or even through Spark's own cluster. Alright. Next we have is polyglot. Well, simply it means that it supports multiple languages like R, Python, Java, and Scala. It basically provides the shell in Scala and Python, which you can access through the bin folder of both Scala as well as the Python. Alright. A question might arise in your mind, like under which situation should I use Python? Or under what scenario should I go with Scala or Java or R? Alright. So let me tell you a fact. The most used programming language with Spark are Python and Scala. Alright. So now if you are going to learn PySpark in this tutorial, it is important that you should know why and when to use Spark with Python instead of Spark with Scala. So let me just compare Python and Spark with some parameters. This will make things clear for you to decide. So our first parameter is performance speed. Python is comparatively slower than Scala when used with Spark, but programmers can do much more with Python than Scala because of its easy interface that it provides. On the other hand, Spark is written in Scala, so it integrates very well with Scala, making it faster than Python. Alright, so next we have is the learning curve. Python is known for its easy syntax, and being a high-level language, it makes it easier to learn. Whereas Scala has an arcane syntax which makes it hard to learn, but once you get a hold of it, you'll see that it has its own benefit. Alright, next is the data science library. Python supports multi-data science and machine learning libraries. But on the other hand, Scala lacks proper data science library and tool. Scala does not have proper local tools and visualizations. Alright. Finally, the last parameter is complexity. So Python API has a simple yet easy and comprehensive interface. Whereas on the other hand, Scala's syntax and the fact that it produces the verbose output is why it is considered a complex language. I hope the things are getting clear to you. So before we dive deeper into the PySpark concept, let me tell you about how big tech giants like Yahoo, TripAdvisor, Alibaba, and other big multinationals are using PySpark for them. Well, Yahoo uses Apache Spark for its machine learning capabilities to personalize its news and web pages, and also for targeting advertisement. And also for target advertising. They use Spark with Python to find out what kind of news user are interested in reading and categorizing the news story to find out what kind of user would be interested in reading each category of news. Next is the TripAdvisor. Well, TripAdvisor uses Apache Spark to provide advice to millions of travelers by comparing hundreds of websites to find the best hotel price for its customer. The time taken to read and process the reviews of the hotel in a readable format is done with the help of Apache Spark. Alright, let's discuss about Alibaba. Well, Alibaba, I guess most of you have heard about it, right? It is one of the world's largest e-commerce platform and runs some of the largest Apache Spark jobs in the world in order to analyze hundreds of petabytes of data on its e-commerce platform. Alright, so I guess now you have an idea that how PySpark is being used in the industry, right? So before I continue, has anyone any doubt up till here? If yes, please add it over to the comment section below and we'll try to reply them at the earliest. So guys, if you're a mobile viewer, get ready with your laptop because now we'll proceed with the installation part. So let's install PySpark in your system. just to keep it real. Just in case you are stuck, you'll find many installation reference out there on the internet, which you can just go ahead and refer to and get installed. So guys, in this tutorial, I'll be teaching you how you can install PySpark on your Windows machine. Alright, if you're a Linux user, add your email ID below and I'll send you the installation step for it. You can just follow it and install it on your machine. Fine. Well, before we actually proceed with the installation part, there are some prerequisites required for PySpark installation that you must know. So as a part of prerequisite, you must have the Jupyter Notebook installed on your machine and you must have an updated version of Java. Alright. So let's just open google.com and just search for download PySpark. Well, I'm assuming that you guys have installed the prerequisite for this session. So proceeding ahead, let's download the Spark. Just Google it, download Spark. The very first link which you'll get is the Apache Spark link. Just click over there and it will redirect you to the Spark Apache website. As you can see over here, the Spark release is 2.4 of November. It's very recent. And the package type which I'm selecting is pre-built for Apache Hadoop 2.7 and later. You have other options available over here. So I'm selecting pre-built for Apache Hadoop 2.7 and later. And finally what I'll do, I'll just click over the download link over here. It will redirect me to a different page where I can see over here it's a mirrored link for me. I'll just click it and my download will start. I think it's a pretty big file. So yeah, it might. So yeah, it's a pretty big file. Just make sure that you have a very good internet connection if you are downloading it. For now, I'll cancel this as I've already downloaded this file. So let's cancel it. Let me just show you where I have downloaded it. And downloads, I have this file. Spark 2.4 Ben Hadoop 2.7. Alright. Just unzip it. Extract files. I'll extract. Just extract the files. The files I extracted, I'll just save it somewhere. Like, let's save it in the D. Okay. By the time it does save it, just open your CMD. So our next step would be to edit our environment variable. So let's create some environment variable using the setx command. My first variable is spark_home. And after that, I'll specify the path of my Spark file. So this is the path. Let's paste it. Done. Okay. Next, I need another environment variable as Hadoop_home. Then again, specify the path of the file. Hit enter. Done. Now, since I want to launch my PySpark shell in Jupyter Notebook, so I need to define two more parameters over here. PySpark driver Python and PySpark driver Python OPTS. Alright. This will help me to open the PySpark shell in Jupyter Notebook. So I'll write setx PySpark_driver underscore Python and IPython. Hit enter. Done. And my next parameter is setx PySpark_driver underscore Python underscore OPTS and notebook. Hit enter. It's done. Alright, let's close this terminal. Now let's open a new command line prompt. Now my first task would be to redirect to this bin folder. Alright, so this is the path. Let's copy it. Jump to the D directory. CD space. I want to go over till bin. So yeah, so there's my path. Hit enter. I'm in bin. Now my next step would be to execute PySpark with the command PySpark. I'll use a master parameter for setting the master node. And since I want 2 cores for local testing, so I'll specify master local. How many cores? I need 2 and hit enter. So what it will do, it will open me a Jupyter notebook on my local host. So yes, we have successfully installed PySpark on our machine. If you are facing any issues, comment it below with the error message which you got, and I'll try to resolve it for you. Okay. So for now, just click on new, select Python 3, and it will open a tab where you can write your PySpark code. Alright. So this is the Jupyter notebook with Python 3 where I'll be writing my PySpark codes. Alright. So now is the time that we start and learn with the fundamentals of PySpark. So now the installation is complete, so I guess we should proceed with the fundamentals of PySpark. So as a part of PySpark fundamentals, so we have SparkContext, SparkConf, SparkFile, RDDs, data frame and MLlib. So I'll start with SparkContext. Well, it is an entry gate for any Spark derived application or functionality. Let's see in detail what exactly it is. So when we run any Spark application, a driver program starts, which has a main function, and your Spark context gets initiated here. The driver program then runs the operation inside the executors on worker nodes. Now this PySpark, it uses Py4j. This Py4j enables the Python program running in a Python interpreter to dynamically access Java object in a Java virtual machine and create Java Spark context. By default, PySpark has Spark context available as SC. So creating a new Spark context won't work over here. Alright. Let's move ahead. So here are some of the parameters related to Spark context. We have master, app name, Spark home, serializer, gateway, con, PyFiles, environment, JSC, profiler CLS, batch size. Among all of these, only master and app name are the one which I use most frequently. So for this tutorial, we'll focus on just 2 of them. The master represents the URL of the cluster it connects to, whereas the app name is nothing but the name of your job. Let me show you this with an example. Let's open our Jupyter notebook. So let's write our very first PySpark code. From PySpark, import PySpark context. Alright. And next we'll define a SC as Spark context. And inside this, my first parameter would be the URL. My URL is local. And my next parameter is the name of my application. I'll name it as anything like my app. So I guess we are getting an error like cannot run multiple Spark context at once. Alright, so you can resolve it just by writing sc.stop. Okay. Hit enter and let's reload it again. Execute it once more. Yeah. So as you can see here, my error is gone and the statement is executed. Alright. So what I did over here, I defined the URL and the app name. Now this parameter, it cannot be changed throughout the program. Alright. So alright, this was all about Spark context. So moving on ahead, let's see another PySpark fundamental. So on the PySpark fundamental list, next we have is this SparkConf. Well, it is used to provide a configuration to run Spark application on local machine or cluster. So what exactly is SparkConf? Well, to run a Spark application on a local or a cluster, you'll have to set few configuration and parameters. And this is where SparkConf comes into picture. It provides the configuration to run a Spark application. Initially what we do, we create a SparkConf object with SparkConf function which will load the values from Spark. Now you can set different parameters using the SparkConf object, and once you set the parameter, 30 minutes, half an hour. Initially, we'll create a SparkConf object with SparkConf, which will load the initial values from Spark. And once set, their parameters will take their priority over the system properties. Alright? Remember, once we pass the Spark configuration object to Apache Spark, it cannot be modified by any user. Thus, it becomes immutable. So we have set master, set app name, get, set Spark home. Alright. So set, it is used to set the configuration property. You specify two parameters over here, key and a value. Fine. In set master, you specify the master URL. In set app name, you set an application name. Finally, there's a get. Get is used to get the configuration value of the key. And finally, there's a set Spark home, which is used to set this Spark installation path. Let me show you this with an example. This should make things easier for you to understand. Alright. So let's move ahead. Alright. So let's jump to our Jupyter notebook. So let's define our configuration file. For this, I'll use from PySpark .conf import Spark configuration. Alright. Next is from PySpark.context import SparkContext. Alright. Next, what I'll do, I'll define a variable as conf, and in it, I'll define my Spark configuration function. Dot, I'll set the app name as set app name, name of my app. I'll name it as PySpark Demo app. And I'll set the master as local 2. Fine. Now let me show you how this get function is working. So since I defined this conf variable, so I'll just write over there conf.get. Inside that value, my value is what? Spark.master. Spark.master. So what it will do, it will give me the master URL which I have already set. Fine. Let's hit enter. As you can see, we got the URL as local2. Fine. Since I have already set my master URL as local2. Now what if I want to check my app name? So configuration.get spark.app.name and hit enter. So my Spark application name was PySpark Demo app. Alright. Fine. Alright. So I guess we can move ahead. So next in the PySpark fundamental we have is this SparkFile. The Spark file, it helps in resolving the path of files added to Spark. Alright, so what exactly is this Spark file? Let me first tell you what it is. So whenever you have to upload your file in Apache Spark, you can upload it using the sc.add file, where sc is your default Spark context, remember? Right. And whenever you want to retrieve the path on a worker, you can get it using the sparkfiles.get. The sparkfiles is used to resolve the path of the file added through sparkcontext.add file. Okay. Now let's talk about its class method. Sparkfile contains two types of class method, get and getRoot directory. Get is used to get the path of that file that is added through the sparkcontext.add file, and getRoot directory function is used to get the path of the root directory added through sc.add file. Fine? Let me make things more clearer with a demo. Alright, so let's check out the demo for Sparkfiles. So from PySpark, import Sparkfiles. Fine. Next, from PySpark, I want to import SparkContext. Next, what I'll do, I'll define my path. Path equal os.path.join, and inside that I'll define the path and the file name. So my path is, this tspark ben. Okay, so yeah, this is my path, and the name of my file is, just copy it, and the name of the file is fortune5002017. Alright, so since I have defined my path, so my next step would be to add the file. So sc.add file. From where? From this path which I have already mentioned above. Now let's hit enter. Oh, what's the error? Okay. So yeah, it got executed. Fine. Now let's check for its root directory. So let's add another. Let's check for its root directory. Sparkfiles.get root directory. Define it. Let's see. So there's my root directory. Alright. So moving on ahead, in PySpark Fundamentals, we have RDDs. Well, there's a very important concept that you have to learn. Alright. It stands for Resilient Distributed Dataset and is a building block of every Spark application. So what is RDD? RDD stands for Resilient Distributed Dataset. Resilient as if the data in the memory is lost, it cannot be recovered. That is, it's fault tolerant behavior. Next is distributed. The data is chunked into partition and is stored in memory across the cluster. And finally, it's the dataset. That is, initial data can come from a file or it can be created using the program. Fine? Alright. So next we have types of operations in RDD. Well, we have two types of operation in RDD. One is transformation and other is action. Let's see about them in detail. So what is transformation in RDD? Well, these Spark RDD transformations are functions that take an RDD as an input and produces one or many RDDs as output. They do not change the input RDD, since I already told you that RDDs are immutable and hence you cannot change it. So what they do is they always produce one or more RDDs by applying the computation they represent. For example, map function, filter, reduce by key, etc. These transformations are lazy operation on an RDD in Apache Spark. It creates one or many new RDDs which executes when an action occurs. Hence, transformation creates a new dataset from an existing one. Certain transformations can be pipelined, which is an optimization method that Spark uses to improve the performance of computation. Next comes the action operations. An action in Spark returns the final result of RDD computations. It triggers the execution using lineage graph to load the data into original RDD. Thereby carry out all the intermediate transformation and return final result to the driver program or write it out to the file system. The lineage graph is dependency of all the parallel RDDs of RDD. Action are RDD operations that produce non-RDD values. They materialize a value in a Spark program. An action is one of the ways to send result from executors to the drivers. Few functions which are a part of it is like first, take, reduce, collect, and so on. Alright. So using transformation, you can create RDD from an existing one. But when you have to work with the actual dataset, at that point you have to use action. Remember, when the action occurs, it does not create new RDD like transformation. Thus, action are RDD operation that gives no RDD values. But in turn, what it does, it stores the value either to driver or to external storage system, thereby bringing laziness of RDD into motion. Well, here is a summarizing image for you. As you can see, when you apply transformation operations like map, filter, sort by or anything, so what it does, it creates a new RDD. Whereas on the other hand, when you have to perform actions like using first, take, etc., then your existing RDD is saved as a file. Alright? So I think you guys might have a question in mind like when you guys should use RDD. Right? Well, here are some of the scenarios under which where RDD is most preferably used. First is the unstructured data. When your data is unstructured, for example, in case of a media stream or stream of text, you can use RDD. Second is the no schema. Well, this is the case where you don't care about imposing the schema, such as the columnar format or while processing or accessing data attributes by name or column. Fine. Next is the data manipulation. That is, you want to manipulate your data with functional programming construct that domain specific expressions. And finally, we have the low level transformation. That is, you want low level transformation in action and control your data set. Alright, so these are the scenarios under which you can use RDDs. So next on the PySpark fundamental, we have data frame. So this was all about RDD. If you have any doubt, don't hesitate in adding them in the comment section below. It will be beneficial for you as well as for the other learners. Alright. So in the next PySpark fundamental, we have data frame. Data frame is a buzzword in industry nowadays. People tend to use it with many popular languages used for data analysis like Python, Scala, and R. So why is that everyone using it so much? Well, data frame generally refers to a data structure which is tabular in nature. It represents rows, each of which consists of a number of observations. Rows can have a variety of data format which can be heterogeneous, whereas a column can have the same type of data type, that is homogeneous. Data frame usually contains some metadata in addition to the data, for example the column and the row name. Okay, we can say that data frames are nothing but two-dimensional data structure similar to a SQL table or to a spreadsheet. Fine. I hope that data frame is clear to you guys. So moving on ahead, in the end we have the MLlib. MLlib is a machine learning API of Spark which in turn supports various machine learning algorithms. It is a machine learning library that is provided by Apache Spark to make the machine learning scalable and easy. It provides various tools for machine learning algorithm, featureization, pipelines, persistence, and utilities. Few machine learning algorithms which are a part of it are classification, regression, clustering, collaborative filtering, dimensionality reduction, and others. Alright. So as a part of featureization, they have feature extraction, transformation, and selection. In pipeline, they have a tool for constructing, evaluating, and tuning machine learning pipelines. Alright. So thank you guys. This was all for this session. In case you have any doubt or queries, feel free to add it in the comment section below. Subscribe and stay tuned to learn more about each individual PySpark fundamental in detail. Thank you.